here we are with question 3. We've got bearings. Mast A is 8.2 kilometers away from point C, from mast C. Yeah, that's important. Mast A is 8.2 kilometers away. So if we draw in that line from C to A, we know that magnitude is 8.2 kilometers. And we know the bearing, measured clockwise from north, is 72 degrees. We can do a similar thing, I'll change colour, with the other piece of information. Mast B is 15.6 kilometers away. On a bearing of 39 degrees. Find the distance between masts A and B, giving your answer in kilometers to one decimal place. So, having filled in that information on the diagram, we can see that going from A to B, the distance we're asked to find, makes the third side of that triangle. We've got two distances in that triangle, two lengths. We can find a third length with the cosine rule, so long as we also know the angle in between those two sides that we have been given. Well, we can certainly work it out. So if all of that distance, all of that angle from north to this line is 72 degrees, and from north to the green line is 39 degrees, then the bit from the green line to the blue line is the difference between those two values. From 39 to 72 degrees is 33 degrees. So that's the angle in between those two side lengths. Now we've got all of the information we need to be able to use the cosine rule. So hopefully you remember the cosine rule, which is that a squared equals b squared plus c squared minus 2bc cos a, where b and c are the two side lengths that we have been given, and a is the angle in between them. So we can just sub that in to the formula. A squared is 15.6 squared plus 8.2 squared minus 2 lots of 15.6 times 8.2 times the cosine of 33 degrees. A is obviously the square root of that. So just find a squared first, or I mean you can do it all at once by putting a big square root around it, but we can just do the square rooting afterwards. Makes no odds really. Whatever you find simplest on your particular calculator. 2 lots of 15.6 times 8.2 times cos 33. So that gives me a value of a squared of 96.03 ... I'm not going to round that number. I'm only going to write down a few digits, but that number goes on, and that's the value that I'm going to use. So I'm just going to square root the answer on my calculator, which gives me A is 9.7997. Again, it goes on, but we only want to give our answer in kilometers to one decimal place. So let's round it now at this point to the correct degree of accuracy, 9.8 kilometers, and we can just restate that we've done that to one decimal place as was asked. Okay, an engineer needs to travel from mast A to mast B. Give a reason why the answer to part A is unlikely to be an accurate value for the distance. Okay, so I'm going to, oh, I can do text box. I was just thinking, it just seems to take me forever to write stuff on this, but I can do a text box. Basically, a lot of people did get this mark because just thinking about the real life situation here helped some people to kind of access what this question was all about. If we're actually traveling between these two masts, we've got to travel 9.8 kilometers. That's as the crow flies, is the phrase that we use. So you can use that phrase if you like. If that's not something in your idiolect, you can put it some other way. But 9.8 kilometers is the as the crow flies distance. What that means is, obviously, if a bird is flying from one location to another, there's no obstacles in its way because it's flying through the sky. So a bird could take the theoretical most direct route between those points. We very likely cannot do that because there's probably something in the way, like a tree that we're going to have to go around, or a road or a river or something. Even if the ground is changing gradient, that's going to alter slightly the distance that we're traveling. So it's really impossible that we're going to ever be traveling precisely the as the crow flies distance. So just say 9.8 kilometers is the as the crow flies distance, which assumes no obstacles in our path. In reality, this would be unlikely, and that's fine. That's fine. You don't have to suggest what the obstacles might be, but if you want to, you can. These 1 mark questions, remember, don't write reams and reams for them because they just don't require it. Okay, good. There we go. There's one more question done. Let's close that one down.